All right, class.
Yes.
Victor. Yep. There we go. He's here. We're good. All right. Finding definite integral using substitution. Now, last one was indefinite, which gives me plus c. Definite is there is bounds involved. There we go. All right. Didn't we already do this one? Yeah, we did, right? Okay. So what did we say u was? Okay. So u was 4 minus x squared. And so du is negative 2x dx. And so what do I have to try and get rid of here? Huh? All the x's, right? And so if I have negative 2x dx, am I going to substitute all that, or can I move? Do I have to move this around? Okay. Do I have a negative 2 in here? I only have an x, right? So that means I only want to take care of my x dx, which is my x and dx. So that negative 2 has to go to the other side. So I'm going to divide both sides by negative 2. So I get negative 1/2 du is equal to x dx. All right, so I'm going to start replacing some things. So I'm going to go and my x dx, so that's going to give me integration from 0 to 2 of u to the 1/2 du. Hmm?
Oh no, wait, no. Oh, it's integral. So instead of doing like the whole u with the indefinite integral.
Yeah. But there's two ways of doing this. So this is the first way, which is going to be a bit longer. This is called put it back method. I just made that up right now, but it's basically what do you do with it? You put it back. All right, so let's go ahead, do your thing. So I'm going to go u to the 3 over 2 times from 0 to 2.
Just fill it in.
Hmm?
And just fill it in.
Okay, so right now, these bounds here are bounds pertaining to my x, aren't they? But I'm on the u, right? So when I do this, I need to first put it back and then evaluate it here. So by putting it back, I'm going to have 2 u.
Easier to derive or anti-derive.
Hold on, let me put it u. I didn't want u. I want 2. My u was 4 minus x squared to the 3 over 2 all over 3 from 0 to 2.
It wouldn't there should be x to the third. Wouldn't it be x to the third?
Why would it be x to the third?
Well, at one point after evaluating, then 3 halves times 2.
Okay, so now we're going to evaluate it. Remember, it's always top minus bottom. Top minus bottom. So let's plug it in 2. So that's going to give me 2 squared. 4. 4 minus 4 is?
Oh, wait, yeah, you're right.
4 minus 4 is? 0
With that.
times 2/3?
0.
0. What's up, tree?
You have a type C.
Do I have what?
A type C.
Yeah.
But like a really long type C.
A really long type C.
Because my laptop uses type C. And I forgot my laptop charger.
I do not hear. All my long type C's are in my esports room. So, huh? This is not a C. This one is though. Is that what you want? Yeah? Okay. All right, now top minus bottom. So bottom is going to be 0. So let's see. So 0 squared is 0. 4 minus 0 is 4, right? And when we raise it to the exponent like this, the top is going to be a power, the bottom is a root. What is 4 to the square root? 4, square root of 4. It's going to be 2, right? So square root of 4 is 2. And 2 to the third power? 8. Very good. So I got 8. You guys want me to actually slow down and actually show each piece, or?
So you're using actually, yeah.
Okay, yeah, I'll do that. So we have, it was 2. And so this is going to give me okay. Are we okay with this one?
Yeah.
Okay. And the other one would be minus, so 2, 4 minus 0 squared to the 3 over 2. Right? So this is going to be 2 times 4, 3 over 2. So I'm going to rewrite this. So to show this, so I have square root of 4 raised to the third power. That's what that 3 over 2 means.
So we're looking at, so if there's like a fraction in the exponent, we look at the denominator first.
Denominator, because that's gonna help me out. Because if I do it the other way, what's 4 to the third power? 64. And then it's asking for what's the square root of 64?
That'd be like 8.
Yeah, so it's 8. So right, you could do it either way. In order of operations, we could always do it like that. So we could say instead, we said, so what was it? It was.
That way you just describe it's gonna sound easier.
It sounds easier?
To be honest.
So 4 to the third, and then square root of that, right?
That was easier to me.
Okay, yeah, but sometimes we get bigger numbers than something like, yeah, so I always try and go with smaller numbers first to make it a little bit easier. So I try and do the root first. If there's no root, then yeah, it's going to be super complicated. So that's why I try and take care of that. So if there's no root, then yeah, fine, just stays as whatever number. But if there is a root, like square root of that, it makes it easier, right? So right here, so square root of this, so it's going to be square root of 64, and square root of 64 is 8. So if we do it this way, so I'm going to have 2 times 2 to the third. And so this we did the root first. So 2 to the third is going to be 8. So that's going to give me 8 times 2 is 16 over 3. So the top gave me 0. The bottom gave me negative 16 over 3. Or minus that, right? Now, this is, what do we have to do this? I call this doing what? What did I do here? I just put it back, right? Yeah. Okay, so now I'm going to remove this right here. Okay, so the other method is subbing the bounds. So to show you what subbing the bounds is, because I don't want you guys to have to rewrite everything over again, you just need to rewrite the different method. So this is going to be subbing the bounds. So to sub the bounds, right now I said that these bounds from 0 to 2 is according to this x, right? Why don't we just change the bounds according to the u and leave it alone? So I would still have my integration, and I'd still have my u to the 1/2 du. So if I'm subbing the bounds, I'm going to put my bound into this. Remember, this is a true statement, right? If this is a true statement, then my u, what would my u values be? It would be determining on plugging into there, whatever I'm subbing for my u. So right here, let's plug in 0. So if I plug in 0, that's going to be 4 minus 0 squared. So my lower bound is going to be 4. My upper bound, I'm going to plug in 2. So that's going to be 2 squared is 4. 4 minus 4 is going to give me 0. And when my bounds are backwards like this, what type of answer do I end up with? When I change it? Negative, right? So if it goes backwards, then I end up with a negative answer normally. Okay, so let's go ahead and take a look now. So same steps. So it was 3 over 2 u to the 3 over 2 from 4 to 0. So top minus bottom. Right? And that's going to give me 4. Let me see. So 0 top.
Oh, it's 0, yeah. 0.
Yeah, so it's times 0. Minus bottom, which is going to give me, let me see, 3 over 2. And that's going to give me 4 to the 3 over 2.
Exactly what we had.
Yeah, so I get that. So square root of 4 gave me 2. 2 to the third power is 8. And multiply that out. Oh,
Oh, wait.
what's wrong here?
You meant 2/3, no? Yeah, you meant 2/3. 3 over 2 as the exponent, so it's going to be 2/3.
Oh yeah, it should be 2 over 3. I'm sorry. There we go. Yeah, I flipped it over. Thank you for that. So yeah, 2 over 3 here. Like why? All right, so we end up with the same answer as negative 16 over 3. Right now, you subbing the bounds seems like it's more work. It's going to be helpful later on when you get more complicated problems that you're not going to want to sub, or you're not going to want to put it back in later. So you subbing the bounds saves you a whole bunch of time on some of the more complicated problems. And sometimes it works out better by not you subbing.
But don't you have to put u into it?
Okay, see this right here?
Yeah.
So this is you subbing bounds. So all I'm doing is right here, these bounds are related to the x value. These bounds here are related to my u value. And that's why I took this here to actually get my new bounds. For whatever I'm substituting for u, I could substitute my bounds also.
What happened to the multiplying by x?
Multiply by x. Okay, see this right here?
Yeah.
X dx. Right? So my x dx got substituted out. So everything all the way to here.
Oh, I see what you're
Not sure what's going on.
I see.
Did I miss something?
No, I just.
Yes, I did.
Yes, it did.
Negative.
Ah, thank you. Man, I am not on top of things. So that means that on my other one, this one, I was still missing that also. So over here, since I got the same thing, that my final answer should be a positive 8/3. And then if I go back to fix this one, because I left off that, and so because I'm distributing that -1/2. Where were you on that one, Joseph? I could have used your help there. Thank you, Tree.
So you keep making it the x, you know the balance during x, in terms of x, and doing it in terms of u, so you can substitute the balance into just u instead of substituting x.
Give me 1 second. Let me see. Okay, so you ready? No, Blade, you ready? You're walking me through this. You ready?
Yeah.
So I look at it first and I say, hey, what do I want to get rid of? What is part that I look at and be like, hey, that would be a chain rule?
Oh my god.
The
2 theta, okay? So I'm going to say u is equal to 2 theta. All right, next step.
2 theta, we find, no, we do du, we find what's it called, the derivative.
Yeah, so du.
So 2 theta.
Remember, it's derivative.
It'd be just 2 then?
Yes, it would be 2 what?
2 d theta.
D theta, very good. 2d theta.
And then we want to get rid of, yeah, so we're going to divide both sides by 2.
Very good.
We get d theta by itself.
Yep. So they'll take care of that.
And then
What about the 2 I already have in there?
the 2 you already have in there. It will,
It's on the bottom, right?
so it will be, no.
I think you got it.
Can we get rid of it?
By, can we put it in front?
Yeah.
As a 1/2, wouldn't
Yeah,
it?
1/2.
So it would be a 1/2 in front of that. But I also have a 1/2 over here, right?
So it'd be 1/4.
Very good. 1/4. That's what I'm looking for. So it would be a 1/4 integral. And so I took care of this, I took care of this, and I took care of the 1/4. Okay, or the other 1/2. And so now it's going to be 1 minus cosine of u du.
It would be
Hold on. Tell me the step that we're doing,
Or
because I'm letting you choose at this point.
okay, we're gonna find the you call that the antiderivative or the integral. What do you call it?
Okay, so you're gonna do this first. Which method are you gonna do? Are you gonna do the put it back or u sub bounds?
We're gonna put it back.
Put it back. Okay.
Yeah.
So that means that these bounds stay the same.
Yeah.
Okay.
So now we're gonna find the antiderivative. I don't know what the other ones.
Integral.
Integral. It'll be 1/4, and then yeah, that's where it'll be theta, right?
Not theta. What's my variable here?
Variable will be u.
Yes. So thetas are over here, right? I got rid of all the thetas. So over here, the one I'm using is a u. So it's going to be u.
U, and then minus no. It should be negative sign, right?
Okay, let's look. So sine, negative sine, cosine, negative cosine, right?
Yeah. So this should be negative sign.
So right here, I'm going from negative cosine, it's going to negative sine. Okay, good.
Negative sign.
Sine of what?
U.
Very good. From?
From 0 to pi half.
Yep. Very good. Good job.
And then you put it back.
Put it back. So that's going to be 1/4. Theta is, I'm sorry, u is,
U will be 2 theta.
so everywhere there's a u, I'm going to put 2 theta.
And minus sine 2 theta.
From,
Yeah.
like that.
Substitute the theta. Wait, no.
Now we're all in thetas again, right?
Yeah. So you substitute the thetas, right?
Huh? Yeah, so now I could actually replace theta with,
Pi halves. Right?
which is top minus bottom, so that's going to give me, let's see, I'll write out the whole thing for you. So it's going to be 1/4, because I know you're still trying to catch up writing this, right?
Yeah, I'm trying to write it out. And in that section, minus the bottom.
Give me 1 second. Yeah, minus the bottom right here.
Minus sine 2, 0. So we can find what both sides equal to.
Mm-hmm.
So the first side, the top will be, so that'll be pi.
Very good.
Pi minus, so that's
2. Oh, wait, I didn't replace it here. Sorry. So it was 2 times pi over 2.
that'd be sine pi, so that'd be, well, okay, I'll go with sine pi will be, I don't do that.
Go ahead, tell me.
It'll be 0, but there's a negative, it'll still be 0.
Very good.
And then that minus 2 times 0, it'll be 0, minus sine 0, which is 0. So it'll be pi. So, oh no, then you times that by 1/4, so that'll be pi 4.
Very good. See? You got this. What's helpful? Writing down and talking through the steps?
I guess you have to talk through the steps.
Okay.
I'm able to remember most of it. Except I don't really. Well, is it like for doing the balance thing you said? Do you have to do that? Like, is there a time where you have to do that?
When the problem is more complicated. Yeah, when it's more complicated. So right now the ones that we're doing are simple. Okay? Other ones it's going to get really complicated and you're like, okay, I don't want to. there's going to be times that you actually have to sub twice, or even 3 times. So you're going to sub a U, you're going to sub a V, and you're going to sub a Z, or an alpha, zeta, delta. Yeah, there's all kinds of Greek letters you're going to have to use. Huh? Yeah, Calc 3 you actually have to do multiple. So you're doing like 3-dimensional. So you would actually be doing like an implicit with multiple bounds. So you're going to bound it by your x-axis, and you're going to bound it by your y-axis. So you're going to have a double integral.
Do you have any of those complicated problems?
No, because that's Calc 3. You're not doing it right now. No. So you don't even have to worry about double bounds. Okay? So you feel happy about this now? Let's see. All right, odds and even functions.
Did you still want to give us time?
I'm trying to, but I'd rather actually walk you through a problem and make sure you understand it versus I finish it real quick and then you're stuck on the homework because you're like, I care more for understanding. But yes, we will still have, if we stop right now, it's 15 minutes. So let's take a look. Important. Even function is going to look like this. Odd function is going to look like this. So when it's an odd, you're going to have here, and it's going to be a top minus a bottom. Because down here, this is negative. Down here, this is positive. And if it's top minus bottom, it should come up to be 0. Right? Okay. And now this one right here is an even function. And so from here, we're looking at it, and we could actually rewrite this if we know it's an even to be from here going this way. And just say 2 times this to be able to get that. That's the difference there. Because you're going to have some homework problems that actually say odd function or even function. And then you're gonna actually use that rule. Okay, even function, then it's there, odd function there. Okay. So, what type of function is this one right here? Okay, what type is this one right here? How do I tell? It's the highest degree. The highest degree determines the shape. So like if it's a parabola, that would be an x squared, right? But does it x to the 4th have the same shape? Does it x to the 6th have the same shape? There we go. So an even function would be x cubed, or yeah. I'm sorry, x cubed would be an odd function, sorry. So x cubed is an odd function, so it'd be like, the graph that we saw earlier, kind of like that, over and above, like this, right here, you're going to have, a negative and a positive that's going to cancel out, and you should end up with 0. So, in the case that this is a odd function, what's my answer? 0. To get the answer for this even function, I'm going to change this. It would be 2 times 0 to x4 minus x squared plus 3 dx. So that's going to give me x5 over 5 minus x3 over 3 plus 3x from 0 to 2. Why is this one going to be easier? And it's because my favorite number. You guys remember what my favorite number is? 0. Anything times 0 is? And so if I plug in the lower bound right here, what's that going to give me? It's just going to give me 0, isn't it? So that's going to be a lot easier, so it helps me out there. So it's going to be 2 times that. So as I plug that in, so that's going to be 2 bracket 32 over 3 minus 8 over 3. No, that's not 3, that's a 5. Sorry. Plus 6. And then all this is going to be lower bound minus 0. Yeah. And whatever that answer is, that's where we're going to get it.
So is there always a 2 in front? Like for even function?
Yes. That's kind of what the formula was right there. So there's a 2 in front of it. What's that going to be? That's going to be, what's it? 10 2/3 minus 2 2/3 plus 6. That's going to give me 8 plus 6 is 14. 14 times 2 is. Anyone want to check my math on that? Because I'm not very good at math, so I need someone to help. Do you agree, Victor? Or are you still working on that part? Okay. Tree's shaking his head. He agrees with me. For what? The bottom? The top or the bottom?
Top.
Oh, the top? The top, I'm plugging in 2.
Yeah.
So 2 to the 5th is 32. So 32 divided by 5. Oh, wait. It's over 5. That should be.
Wait, but I see like the second piece at minus. Is that 0 over 0? I mean 0 to the 0 power.
Yeah, 0 to the. No. I'm sorry. I think I messed up mine right here. It's supposed to be a 5. And yeah, that's where I made my mistake. So that's not 10 2/3. That's 6. Let me see. 6.4. And which way? So 2.
I got 19.46.
19 point what?
I got 19.46. But I'm not entirely sure.
0.46. Is it just exactly 46, or was there a third decimal?
Wait.
There should be a third decimal because this is a repeating.
I think I'm wrong.
It's just 19.46 repeating.
Oh, 6 repeating? Okay.
But I did the math you did right there.
Okay.
Like I did that one first, like with the fractions.
Yeah.
I did what you did right there, and it's different as is.
This right here?
Yeah, I did that one, and I got 19.46. But then I did
With the decimals?
Yeah.
Okay. So 32 divided by 5 is going to be, so 5 goes on 32 6 times.
It'll be 6.4. Yeah, you're
Six-
right.
6.4
8 divided by 3.
is 2.6 repeating,
Yeah, you're right about that one.
and then plus 6.
I don't know. That's weird. Maybe I just put it wrong in the calculator.
No worries. Yeah. All right. So, all right. So from there, I'm hoping you guys should be ready. Today is what date? Today's Thursday. There is advisory, so if you're having trouble and actually need help getting this, so you do not, try to wait until 12:30 after the due date to actually turn it
I
in.
was busy that day.
Listen.
I still
Just
got
do
it.
it now. Do it now. All right.
I
Like,
don't
share,
work
subscribe.
every day.
Huh?